Hello, my name is Dikanev Pavel. I want to present you our article with Yulia Vybinova. It's method for protection of PDF documents against counterfeiting using semi-fragile watermarking. As a rule, digital signatures or EDS or cryptographic hash functions are used to protect PDF documents. EDS and hash functions provide only integrity protection, but for comprehensive protection and understanding of the article goals, it's necessary to be able not only to authenticate the document, but also to localize fragments that were attacked and modified. The developed authentication method should include the ability to localize malicious changes. To be able to localize these changes in the document, it's possible to use steganographic inserts or digital watermarks. A digital watermark is a special mark embedded in digital content called a container in order to protect copyright and confirm the integrity of the document itself. The following body requirements were put forward: the ability to authenticate PDF document, the ability to localize malicious changes introduced into the document, the ability to transfer text string inside the watermark, visual indistinguishability of the original document, and the document with an embedded watermark. The impossibility of removing the watermark by unauthorized persons. In accordance with the previously indicated requirements, the digital watermark should be invisible and semi-fragile. To fulfill this condition, it's necessary to choose the correct method for embedding the digital watermark into the container. To minimize the impact when embedding the digital watermark on the page, it was decided to use a combination of discrete wavelet transformation or DVT and the least significant bit method. It's LSB. QR code turned out to be a suitable digital watermark. A QR code is a two-dimensional barcode containing from black squares arranged on a square grid with a white background. QR code has some duration parameters. Its version is an integer from 1 to 40 that controls the size of QR code. Error correction manages the correction of percentages of errors used for the QR code from 7% to 30%. Information capacity is a maximum amount of embedded information in bits, which depends on the parameters of the QR code. For example, with version 1, its matrix size 21 on 21 and correction level L. It's 152 bits. The idea of the method is to embed the bits of a QR code formed from the page number and the secret key into a PDF document to provide the possibility of detection and localizing removal additional reordering pages. Next, in this case for protection, we use next embedding scheme. It consists of watermark generation, QR code, resizing of QR codes, the next QR codes transformation to bits, PDF transformation to black and white pages, resizing it, velvet transformation, next least significant bit embedding watermark, violet transformation and resizing and converting to PDF. Extraction scheme consists of preparation of PDF document, discrete wavelet transformation, extraction bits, get image. Next, we get image from these bits, apply filters, and read secret message. If authentication fails and the integrity of the document is compromised, the method offers the ability to localize malicious changes in the document. This is possible due to protected properties of embedding the discrete wavelet transformation. Possible attacks that the method allows to localize is forgery of a document by substitution, forgery of a document by changing page fragments, and changing the order of deletion of document pages. We can see some examples of temper localization. Based on the results of the study of the varieties of the QR code and experiments with the application, it was decided to use version 1. It's error correction M. Message size is 128 bits, and various combination of the following parameters of embedding were investigated to find the best balance between robustness and fidelity. It's first and second level of discrete value transformation, LL, LH, and -L subbands of DVT, and 4 or 5 bit layers, least significant bit embedding. For watermark stealth and reliability, the most important on the final image. On the final image, some meshes will be calculated to measure the obscurity between the original image and the image from the digital water center. So standard deviation MSE, peak signal to noise ratio PSNR, and structure similarities SSIM. GVT decomposition is carried out on the second level HL component. This property was revealed experimentally, reflected in tables and figures. There is a difference in the resistance of different regions to various distortions. Embedding into the large part tolerates distortions a little worse, but according to the sum of the previous experiments, the difference is not very significant, since the use of the large component allow you to hide changes in the image container. At the first large level, the image becomes visible to the naked eye, and the resistance to noise and distortions at the third wavelet transformed level is practically absent. So the second level of discrete valued decomposition is optimal. A JPEG page with an embedded QR code was compressed into 3 discrete valued transformation levels according to the results of the experiments presented in tables. Several conclusions can be drawn. The method has resistance to compression. In some cases, compression up to 70% is possible. The most stable embedding is possible in the LL component of the first level of discrete value transformation. The compression characteristics of the LL and LH components are sufficient. The study of resistance to image noise with 3 noises was carried out. Noises Gaussian, salt and pepper, and speckle. According to the results of the experiment presented in table, we can conclude that the developed method is the most resistant to random noise, salt and pepper. In some cases, 15 of the image may be noisy. Next, investigation of the watermark capacity. Display as that we can use DVT level 1 or 2 with message size 128 bits. As a research results, we can see that most quality results when using LH decomposition components of 2-level discrete value transformation and 5 least significant bit layers. Embedding of the digital document doesn't cause noticeable distortion of the container. Embedded information is retrieved without loss of information. The developed method demonstrates sufficient resistance to compression of the code carried up to 50%. The developed method demonstrates a sufficient resistance to noise of the original carried up to 15%. In conclusion, we have studied the existing method of protecting PDF documents, method for authentication PDF document based on embedding digital watermark presented in the form of QR codes has been developed and implemented in software. An argument for embedding the digital watermark into the area of discrete wavelet transform of a PDF document has been developed. An algorithm for localizing malicious changes made to the document has been developed. The efficiency of the developed method was experimentally investigated on various test data, and the analysis of the quality of developed method for protecting PDF files is carried out according to the criteria of visual indistinguishability of the digital watermark, the information capacity of the digital watermark, and the resistance of method to attacks aimed to removing the digital watermark. Thank you for your attention.